Software project management for any project may it be related to software or may it not be. Management of software is an important aspect which is carried out, and if the project is not properly managed, then there is a chance of failure, cost overrun, schedule overrun. So today we are going to talk about project planning introduction and software cost estimation, which include cost estimation models, software size metrics, empirical estimation, heuristic estimation, and COCOMO. Then also how to estimate the staff, that is staffing level estimation, and effect of schedule compression on the cost. Summarize. So, why do projects fail? This is because of improper management. If you have a faulty project management, the software project or any project per se are bound to fail. So it becomes important to learn various aspects of software project management, which is the topic of today. What is the goal of software project management? Why do we go for software project management? This ensures and enables the people who are involved in the software or engineers, more specifically, to work efficiently towards successful completion of a project, software project. So what are the responsibility of project managers? What are expected out of project managers? First is they are supposed to write project proposal. They have to propose that what they are going to make, how they are going to make, what will be the cost, what will be the requirement staff, all these time, schedule, etc. will be in your project proposal. Then cost estimation. This is also the responsibility of project manager. Scheduling. Schedule of piecewise scheduling of the software project. Staff, how much or how many people are required, what for they are required, what for they will be relieved, all these, the amount also, the salaries, etc. Then monitoring and control. All through the the duration of project, while the project is going on, monitoring and control is an important aspect. Then come SCM, software configuration management. This involves change. So whatever changes are going on, this is also the responsibility of project manager. Then assessing the risk and trying to resolve the risk, that is risk management. This is also the responsibility of project manager. Managerial report writing and presentations as and when required. This is also the responsibility of project manager. So there are various project manager activities, the activities which project manager are supposed to do, but we can broadly classify it into, first is project planning and then monitoring and control activities. So once this project is supposed to be feasible or a feasibility study has been carried out, the project manager can commence the planning of the project. So first they start with estimation. These are the activities, project planning activities. For example, effort, the cost, the resource that will be required, and the duration, the time it is going to take for the completion of the project. Then scheduling of the project, staff or staffing plans, risk handling. First they identify risk, they analyze, then abatement process, how to get rid of them, avoid them, ignore them, or rather compete with them. Then we have miscellaneous plans like quality assurance plans, configuration management, that means change or changes. So what this project planning requires is, it requires tremendous amount of care and attention, which involves commitment to unrealistic time and resource estimates that may result in, first is, if you are not planning project properly, then there will be delays, so it will be quite irritating. Customer will be dissatisfied, and then there will be adverse effect on the team morale and poor quality work, and then finally the project failure will happen. So there is a planning strategy which we call as sliding window planning. What is this sliding window planning? This sliding window planning, it involves project planning over several stages, various stages. Project managers from making big commitments too early, first, then more information becomes available as the project is underway. that will facilitate accurate planning. So rather than going for it or making the commitments, it is always better to say or give more comprehensible or proliferated understanding or commitment only when the actual project is facilitated or it is in your hand. SPMP document. What is this? Once this planning is complete, then we document the plans. If you are going to document, you have to have a name of the document. So we call it as SPMP, that is Software Project Management Plan document. So what will be the organization of this SPMP document? It will start with introduction, which will have objectives, major functions, performance issues, management and technical constraints. Then the project estimates, which involves what was the historical data, what was the estimation technique being followed, the effort and cost, and project duration estimate. Then project resource plan. This is about people, hardware and software, and any other special resource which the project is demanding. Then of course the schedules. This involves the work which is there in breakdown into various structure. Then task network, Gantt chart representation, and PERT chart representation. Then the important part is risk management plan, which will present the risk analysis, risk identification, risk estimation, abatement procedure, how you are going to deal with it. Of course, the project planning and control plan, and finally the miscellaneous plan, which includes your process tailoring and quality assurance. So software cost estimation, this is very important aspect and mostly asked in the examination. We determine first the size of the product. And then from the size of the estimate, we determine the effort which is needed. From size, we come to effort. And then after this effort is estimated, we try to determine the project duration and the cost. So this software cost estimation, how it goes or what is the flow is first we estimate the size. Then with the size, we try to estimate the effort and duration. Once we have effort, we can easily estimate the cost. Once we have the duration, estimation, and effort, we combine them to go or estimate for staffing. And if we have staffing estimation and duration estimation, we can go in for the proper scheduling. So in this software cost estimation, there are three main approaches to this estimation. One is empirical, the other is heuristic, and the third is analytical. These are three main approaches to estimation: empirical, heuristic, and analytical. What are the empirical techniques? This is a guess, but this guess is based on past experience. While this heuristic techniques, it assumes that the characteristics to be estimated that can be expressed in terms of some mathematical expression. So characteristics, if it can be represented in the form of mathematical expression, we call it as heuristic techniques. While analytical techniques, this is derived, which is supposed to derive the required results. We start from certain simple assumptions. These are analytical techniques. Then we come to our software size metrics. This is an important ingredient or element, which is line of code. This is simplest and most widely used metric, line of code. We do not count the comment and blank lines. But what is the disadvantage of using LOC or line of code? People generally, count it in kilo line of code, KLOC. Because the size can vary with coding style. Everyone has a different style. Some would require more lines to perform a particular function. The others may require less than what the others may require. So it focuses on coding activity alone. But what about the other parts, other phases? Because coding generally takes around 20% of the time, our effort. So this actually, LOC correlates not very impressive, in an impressive manner with quality and efficiency of a code. So this correlates poorly with your quality and efficiency of a code. And then it also penalizes this higher level programming languages, which is code reuse, etc. The measures which are lexical or textual complexity, These measures are only computed. So it only measures this lexical or textual complexity. And it does not deal with or address the idea of the complexity which is related with structural or logical complexity. It is not going to address the structural and logical complexity. And it becomes difficult to estimate the LOC from problem description. So if you really want to do it for project planning, then it will be difficult from LOC alone. Then the other is FPM or function point metric. This somehow overcomes some of the shortcomings of LOC metric which we just discussed. And this was proposed by Albrecht in early 80s. This is how he managed the expression to be. FP or function point would be equal to 4 into inputs plus 5 into outputs plus 4 into inquiries plus 10 files plus 10 interfaces. What is the input? This is a set of related input which is counted as one input. Okay, the input is a set of related input which can be counted in one input. What is output? Again, the set of related outputs is counted as one output, but it has to be related outputs. What about inquiries? Every or each user query type is counted. What about files? These files, they are logically related data and thus can be data structures or physical files, right? So data structure and physical files, they are generally regarded in files. If some other system is involved, then there will be a data transfer. So that will come under interface. Function point metric, it also suffers from disadvantage or drawback. That is, the size of a function is considered to be independent of its complexity. This is what is not the actual case. The size of the function is considered to be independent of the complexity, but the case is otherwise. So we extend function point metric, then we come to feature point metric, and we consider an extra parameter which is the algorithm complexity to deal with this drawback. The proponents claim that FP is language independent function point metric, and also from the problem description itself the size can be easily derived. But the opponents, those in favor, they claim that these two are true, but the opponent claim that it is subjective. Different people can come up with different estimates for the same problem. So the opponent or those who do not advocate this claim, they suggest that for the same problem various estimates can be generated. Then we come to empirical size estimation technique. So what is the expert judgment on this? A euphemism for guess made by an expert, and this suffers from individual bias. Expert judgment, somebody has judged, we call him as an expert, and if he is expert, that is very good, but this may be his individual biasing. Then we have Delphi estimates that overcomes the problem of expert judgment. It overcomes some of the problems of expert judgment. Expert judgment, what experts are, the experts divide a software product into component units like GUI, database module, data communication module, billing module. So all those parts which can be easily divided and do a specific work. So the division is on this basis. And then they add up the guesses for each of the components. They combine them. In Delphi estimation, there are a team of experts and then a coordinator also. So there are various experts, they carry out this estimation independently, differently. And they talk about the idea or the importance or rationale why they have estimated in this manner. And coordinator, he notes down. He tries to find out the extraordinary rationale which actually circulates among experts. Then experts again do the same work. They re-estimate. Experts, they'll never be meeting each other to discuss their viewpoints. Then comes the heuristic estimate techniques. What is heuristic estimate techniques? As I suggested, if we have a single variable model, then we can estimate a parameter to be some estimated characteristic with some constant. This is single variable model. We can also have multi-variable model, and in this we assume that the parameter which is to be estimated, because this is estimation technique only, it depends on more than one characteristic. Not one characteristic, but more than one characteristic. So how we estimate? So the parameter to be estimated, this can be something like this plus the other one, C2 estimated characteristic into D2, and so on and so forth. So this is always, most of the time, better than the single variable models. Then we come to COCOMO model, constructive cost model, COCOMO model, and this was proposed by the eminent, most respected in software engineering field, Mr. Boyer. It divides software product development into three categories. He says first is organic, the second is semi-detached, and third is your embedded. Organic, semi-detached, embedded. So COCOMO product classes, these three we have seen just now, organic, semi-detached, and embedded. It roughly corresponds to, first is the application, the utility, the system programs respectively. So the data processing and scientific programs, they are considered to be the first part, that is the application programs. The compiler, linkers, and editors, they are supposed to be utility programs. And the operating system, real-time system programs, etc., they are system programs. What are these product classes? Let us elaborate them first. Organic. If the groups are relatively small and they are working to develop well understood application, then they are termed as organic. Semi-detached means when the project team consists of mixture of experienced and inexperienced staff. So if you have a project team in which we have some people who are quite experienced, some are not, so the product class would be semi-detached. Embedded would be the software is strongly coupled to complex hardware or real-size systems. So whenever we talk about a real-time systems or some systems of this category where complex hardware is involved, then these are embedded systems. These three categories, for each these three categories, product categories, for size estimation, which is actually in kiloline of code, Boyer has an equation to correct. First for project duration in months, and then we have effort in programmer months. And he obtained this equation examining the historical data which is collected from large number of actual projects. This is not just he gave an idea and he had a dream and he gave an idea. He actually took the statistics, the history, the information of various large products and examined and then gave these expressions. So software cost estimation is done through three stages: basic COCOMO, intermediate COCOMO, and complete COCOMO. For basic COCOMO model, it only provides approximate estimation. First is effort, that is A1 into KLOC A2. Time of development will be B1 effort into B2. And this is actually, I'll tell you what all this is. So KLOC is nothing but the kiloline of code. This A1, A2, B1, B2, they are all constant for different categories of software products as we have seen. These three categories: organic, semi-detached, and embedded. This time development is the time which is required to develop the software in months. While this effort estimation is obtained in terms of person months. How many person months will be there for an effort. Then we come to development effort estimation. First is your organic. 2.4 into KLOC, and this is the power. 1.05 is the power. Person months. Semi-detached is 3.0 KLOC to the power of 1.12 project months, person months. Embedded is 3.6 KLOC to the power of 1.2 person months. So organic, the time of development, this was actually effort. So we have time of development also. 2.5 effort to the power of 0.38 months. Semi-detached would be 2.5 effort to the power of 0.35. These are all power, right? 0.35 is the power. Months. And embedded would be 2.5 effort, 0.32 effort to the power of 0.32 months. So the effort in basic COCOMO model is somewhat superlinear in problem size. As you can see from this effort to size graph, that the effort is superlinear in problem size. So this is embedded one, red one, semi-detached is blue, and organic is the black one. In this basic COCOMO model, the development time is sublinear function of product size. It depends on in the form of sublinearity of product size. This is 30k, 60k, so it increases around this. When the product increases or product size increases twice, the development time does not double. See, from 30k to 60k, it should be 24k as normal mathematics goes, but it is not like that. It only becomes 18 months. So the time taken is almost same for all the three product categories, whether it be embedded, semi-detached, or organic. Therefore, this development time it does not increase linearly with product size, as we have seen in the graph also. For larger products, more parallel activities can be identified, which can be carried out simultaneously by a number of engineers. There is no question that only few people will not be working. There will be concurrent activities that may be going on. So development time is roughly the same for all the three categories as we have just seen. For example, if we have 16 kilo line of code program that can be developed in approximately 18 months. This is regardless of whether these three categories are there. So there is some scope of parallel activities for the system and application program also than the utility programs. For example, let us take an example. This is the size of an organic software product has been estimated to say 32,000 line of source code. So the effort would be simply we'll put the formula 2.432, that is KLOC to the power of 1.05, that will be around 91 pm. And what will be the nominal development time? It will be 2.5 into this effort will place here, and to the power of 0.38, that will be 14 months. Okay, this is how it is going to work. Intermediate COCOMO, the basic COCOMO we have seen, it assumes that the effort and development time depend on product size alone. But there are several other parameters that affect effort and development time, like reliability requirements, available of this case, computer-aided software engineering tools, and modern facilities to the developers, and also the size of data to be handled. So, to estimate it more accurately, the effect of all relevant parameters has to be considered. And the intermediate COCOMO model, this recognizes this fact, this intermediate COCOMO. It actually recognizes this fact that the effect of this relevant parameter, it needs to be considered. So it refines the initial estimate obtained by this basic COCOMO, as we have seen, by using a set of 15 cost drivers. We call them as multipliers. If modern programming practices are used, then these initial estimates, they can be scaled downwards. But if there are stringent reliability requirements of the product, then we scale up the initial estimate. Then we rate different parameters on a scale of 1 to 3, and depending upon the rating which we have given from 1 to 3, we multiply the cost driver values with the estimates obtained using the basic COCOMO. Please understand, we multiply cost driver values with the estimate obtained using this basic COCOMO. So what are these cost driver classes? First is product. All the inherent complexity of the product, reliability requirement of the product. The computer means execution time, storage requirement. Personal means experience of personnel. Development environment means sophistication of the tools used for software development. So this was the first installment of our project management. We are going to cover more of it. Thank you so much. Take care.